Hello everyone. So today we are going to see following MATLAB functions, which is defining arrays, then array manipulation, then defining matrices, matrix manipulation, special matrices, and rank and inverse of a matrix. Okay. So let's start with the tutorial. So in the previous lecture, I have asked you to plot a circle of a user defined radius with the help of input commands. Over here I have taken radius as an input, and input, enter the radius of a circle, then it will prompt for a radius of the circle. So I will take some constant 2. Okay, then now remaining thing will be the same, just I'm copying it over here. Okay, so I am taking a theta array using the command linspace 0 comma 2 pi comma 100. It will create a vector theta from 0 to 2 pi having 100 divisions. Okay, then we'll define an x as r cos theta. Now over here x is a function of theta and r both, okay, which will generate x coordinates in an array, and y equals to r sin theta, which generates y coordinates in an array. Okay, so I have taken over here semicolon, so this semicolon will suppress the result on the command window, and but it will store these results in the workspace. Okay, so let's plot a circle. So this is the circle. Okay, I have plotted and taken the axis equal. It divides the axis on equal scale. Then title I have given a circle of given radius r. So you can see in this plot the title is on the top. Okay, then this is a proper circular image. Okay, so now we can start with defining of arrays and matrices. So let me clear this space first. Okay, so I've cleared. So now we'll start with defining of arrays. Okay, so for array, let's take a vector x. So we'll define some random array. Okay, so this array, this will give you a row vector. Okay, and this will give you a row vector having 1 2 3. So over here you can see the size in the workspace, that is 1 into 3. So row is 1 and column is 3. So we'll define another vector y. So 1 semicolon 2 semicolon 3. Now this will define a column vector. Okay, over here you can see in the workspace the size is 3 into 1, which is column is 3 and row is row is 3 and column is 1. Okay, so we use semicolon to define a column vector, and in order to define a row vector there won't be any semicolon. Also we will use over here which is square brackets. Okay, we won't use round brackets, we will using square brackets. So now next is transpose. So if we want x transpose, okay, so just a simple x dash we will use over here. Okay, this. Okay, then we will get x transpose. Okay, over here you can see that it has changed its size. Instead of 1 into 3 it is 3 into 1. Okay, so rows has been converted into column. Okay, so now next is size. So if you want to check the size of the matrices, okay, or vector, then we have the command size. So you can look it with the help command, help size. Okay, so over here help size, so it gives the size of array. So size x for m into n matrix returns the 2 element row vector. Okay, and over here if you're okay, let me clear. So if I want to check the size of x, okay, so size of x gives you 1 3. So this first one is always row, second one is always column. So you can put into a vector also in a vector form, mn equals to size of x. So m becomes 1 and becomes 3. okay, where m is the number of rows, n is the number of columns. Okay, so next is array manipulations. Okay, so first of all we'll just add two arrays, x plus y. Okay, so it is giving me some error, okay, that it is saying that matrix dimensions must agree. So we have x which is a row vector and y which is a column vector, so we cannot add if the two vectors are having different size. So it is having 1 into 3, this is having 3 into 1. So I will define another vector a as again I will define a as 1 and 2, okay, and I'll define b as, okay, 3 and 4. Now both of them have the same size, both are same row vector, both has size of 1 into 2, okay. So now I will do the array manipulation. So I will do a plus b, okay. So it is giving me a it is not giving me any error, it is giving me a proper result. So next is a minus b, okay. So I'm getting -2 and -2. Then what about a cross b? So I'll use a special tool over here, a dot cross and b, okay. Remember I'm using dot over here. So this is a very special function of MATLAB. So it gives element wise multiplication, okay. So element wise multiplication, so I'm getting like 1 into 3 and 2 into 4, so this is 3 and 8. Then similarly we can get element wise division, so we are getting 0.33 and 0.5. okay. So now next is scalar multiplication. If I go for scalar multiplication, okay, in case of scalar multiplication I am just multiplying some scalar quantity. I am taking 5 over here with the vector a, so I am getting my answer as 5 and 10, okay. Now if I want to call some array element in a vector, so like if I see the size of a, so size of a, which is 1 into 2. So if I want to call the second element of this array, okay, so I'll just see a, then round brackets, I want to call the second element, so a2. So my second element is 2. So if I want to replace this element with another quantity, if somehow I have taken the wrong element, okay, then I can replace this without deleting the whole vector and starting it from scratch. I will just replace the element 2 with some other scalar quantity as 5. So now my array a has changed from 1 to as 1 and 5, okay. Now if I want to check what is the minimum element in an array a, so I will get the value 1. What is the maximum element value in the array a? So I will use max a, that is 5, okay. If I want to do the sum of the all elements in an array, I will use the command sum of a, so it will give me the sum of all the elements. 1 plus 5 is 6, okay. So now we'll start with next part, which is defining matrices. So I will clear, okay. Now I will start with defining matrices. So I will define one matrix a, I will define some matrix a, 1 2 3 4 5 6 7 8 and 9, okay. So this is a 3 cross 3 matrix, okay. So again I will do some matrix manipulation. So if I want to call, or if I want to retrieve the element at third row and third column, which is the element 9, if I want to retrieve this, so I will use a 3 comma 3. So the first 3 represents the row and the second 3 represent the column. So it is answer a. If I want to replace, some vector. Okay, if I want to replace like 2 comma 1, okay, so 2 comma 1, so the element at row 2 and column 1 is 4, so I want to replace this 4 with some another quantity, like if I want to replace it with 10. Okay, so now I have replaced the quantity 4 with 10 over here, as you can see. Okay, so now instead of calling an element, if you want to call a complete vector or vector, so like if I want to call vector row vector 2 and 3, so I will use some command. Okay, if I want to call the row vector from 2 to 3, okay, so I will call, first is obviously the m is the row and n is the column, so I am calling the row vector 2 and 3, so I am calling the all three elements, so I will use completely as this colon. Okay, if I want to call just first column only, so I will use like 1. Okay, if I want to call only second column, so I will type it over here 2. If I want to call only third column, so I will type here 3. But since I need to call all the three columns, so you can do two things: either you can write 1 is to 3, or if you can just simply write as colon over here, so it means that you are calling all the columns in the given matrices. Okay, so over here we get the answer like this. So we have called the vector the row vector 2 and 3. Okay, so you can put this row vector into some another vector b. Okay, so I'm putting this into another vector b. So now uh, if you want to call some instead of row vector, if you want to call the column vector, okay, so you want to call the column vector, so let's take the vector c. So you're calling the column vector. So for calling vector, so we'll use colon for the row over here. So you want to call the column vector 1 only. Okay, if you want to call the column vector 1, okay, first column, and you want to call all the three columns, then you will use colon, okay, comma 1. Then we get the vector c, which is the column, which is the first column vector of the matrix A. Okay, so now another function in matrix manipulation, like if you want to delete some row or some column, okay, so we'll use this manipulation. So if you want to delete the complete row 2, okay, so if I want to delete this complete row 2, so I'll just write a 2 comma colon equals to, I'll write just a blank. Okay, so this blank will, what will do, it will delete the second row of the matrix A. So like this, my A has been manipulated. Earlier it was 3 into 3, now it is 2 into 3. Okay, so if I want to check the size of A, okay, size of A is 2 into 3. Earlier it was 3 into 3. So again, if you want, okay, so if you want to delete, like if you want to, okay, if you want to delete the first and third row or some like this, so you can use command A. Then instead of writing this, just if you want to delete some random rows, instead of deleting the rows in successive order, so you can write in this way, like first round bracket, then you can use square brackets 1 3. Now since we know that size of A is 2 into 3, so we do not have any second row, we have only like two, we do not have third row, we have only 2 rows. So this command will not give you some answer, it will give you some error, so that it is telling that index of element to remove exceeds the matrix dimensions. Okay, so I will use this command. Okay, with the help of I will just generate another I will generate another A vector. Okay, I'm generating it again. So now we'll see. Okay, so now we can use this command. Okay, So now we have successfully deleted the first and third row completely, and what is left is only the second row, which is 4, 5 and 6. Okay, so like this you can delete, and you can call something, you can retrieve. And how to add some row or some column vector, that is appending of vector in a matrix. Okay, so let's see if I want to add a new vector. So let me clear first, clear and CLC. Now again I will call a vector A, a matrix A. Okay, so here is the matrix A, 3 into 3 matrix A. Now I will define a vector V. Okay, so I will define some vector V, 2, 5 and 8. Okay, now remember, this will give you a row vector. Okay, so this is give you a row vector. Now if you want to append this row vector in this matrix A, so if you want to add as a row, okay, if you want to add this vector V as a row, so just we'll use a square bracket, then A, then semicolon, and then V. Okay, then so we have successfully appended the vector V into matrix A as a row vector. Okay, so now if we want to append this vector V as a column, okay, as a column vector, so what you have to do, see, if I remove the semicolon and use the V, it will give me some error, because there is some error with the dimensions, as you want to add the vector V as column, but vector V is a row vector, so we have to change the row vector V into a column vector V. So we will just transpose the vector V with the help of this apostrophe. Okay, so now instead of AV we will use AV apostrophe. Okay, so A and V transpose. So now we have successfully appended the vector V as a column vector in the matrix A. So over here you need to understand that if there is some issue with the dimensions of vector or matrices, then some matrix manipulation or some array manipulation won't take place. It will give you some error, like in case of a matrix multiplication and division also. So let me take some matrix or some vector x 1 2 and vector y as 3 4. Okay, so now if I want to do some matrix multiplication, so both vector x and y are row vectors, so if I want to do matrix multiplication of x and y, so it will give me some error as both are row vector. So so for matrix multiplication, row is multiplied with column. Okay, so what I need to do is x cross y transpose. Okay, so I am converting row vector y into column vector. Now it will give me some useful answer. Okay, so this is the multiplication of x and y. Okay, now we will see some special type of matrices. So let me clear everything first, CLC. Okay, then some special type of matrices. Okay, so over here we have an identity matrix, so we'll use I m comma n. So then we have matrix of zeros, so we'll use the command zeros m comma n. Over here the e is not there, so do not write z e r o e s, so write it z e r o s. Okay, then we have the matrix of ones. Okay, so let me show you. If I want identity matrix of 3 comma 3, okay, then we get this identity matrix of 3 comma 3 of size 3 and of size 3 into 3. And if I want a matrix of zeros, okay, so I'll get a matrix of zeros and then a matrix of ones. Okay, so like this is a special, these are all our special matrices. Another one is special matrix rand. Okay, so rand 3 comma 3, so it gives you a random matrix. Okay, so let me show you this rand command with help. Okay, so this rand command, it will generate uniformly distributed pseudo random numbers Okay, so remember this point pseudo. Okay, why pseudo? Because this command is using some algorithm to generate some random numbers. So since command is using some algorithm, so this won't be completely random, so it is known as pseudo random. Okay, so over here we are getting uniformly distributed numbers. If you want normally distributed random numbers, for that we have command rand n. Okay, so over here, okay, it didn't take, I'll use again. Okay, then rand n, it gives you a normally distributed pseudo random numbers. Okay, so these are some special types of matrices. Okay, then okay, we have added the vector v, we have added the vector v as both row and column. So this we have done some special matrix. Okay, so the next is the rank of a matrix. Okay, so I'll clear this, clear. Okay, so we'll see the rank of a matrix. Okay, so I will take a matrix A of 3 by 3. Okay, then I'll take a random matrix B of 3 by 3. Okay, so we have two matrices A and B, so we'll see what is the rank. So first of all, let's check this command rank with the help window. Okay, so this rank command gives you the matrix rank. So what it gives you, it gives you that estimate of number of linearly independent rows or columns. Okay, so number of linearly independent rows or column. So over in your mathematics, you know how to calculate all those things, rank and all. So I will use the same matrix manipulation over here. So let me check what is the rank of A. Okay, so what is the rank of A? So rank of A is 2. So what is the size of A? So size of A is 3 into 3. So rank of A is less than your number of rows and numbers of columns. So what it denotes, that if the rank is okay, if the rank is less than the number of rows and columns, then it is a singular matrix. Okay, so it is a singular matrix. Singular matrix, which means that determinant is 0. Okay, so which is non-invertible. Okay, which means determinant is 0, or you can say that the matrix is non-invertible. Non-invertible, which means that you cannot get the inverse of the matrix. Okay, so let me check the determinant of this matrix A. So for determinant we have a command det. So let's check the determinant. Okay, so we are getting determinant very small, it is 10 to the power minus 16. Okay, so over here you can see that this is negligibly and negligible, and this is approximately 0 only. So you can just consider this determinant as 0. Okay, so you can also check the condition of the matrix with command cond condition. Okay, so this condition, it is very large. Okay, so let me check this condition command with the help. Okay, so it gives you the condition number with respect to inversion. So if this is very large, okay, then okay, over here you can see that large over here the large condition numbers indicate a nearly singular matrix. Okay, so for condition of A we get for A the condition is very high, so we can say that it is a nearly singular matrix. Okay, so what about the random matrix B that we have generated? So let's see the condition of this random matrix B. Okay, so it is less, it is not having some 10 to the power x, so we can get easily the determinant also. So if we have the determinant, so it is giving me some positive determinant. Okay, so let's check the rank of this matrix B. Okay, so it is 3. Okay, so the size of B is 3. I will check again. The size of B is 3, the rank of B is 3, so it is invertible. You can get easily the inverse of this rank of this matrix B. You can get the determinant as some positive value. Okay, so this is a good conditioned matrix. So A was the ill conditioned and this was a good conditioned matrix. Okay, so let's check the inverse. Okay, how to check this inverse? For that we have a command inverse inv. Okay, so let's take a vector A inverse, so it will give the inverse of a matrix A. So now over here you can see that we are getting some error because your matrix A was singular, so it is giving you warning that matrix is close to singular or badly scaled, so results may be inaccurate. So it has done some conditioning or conditioned. Okay, it has done some conditioning of this A with itself. Okay, and then given us some value. Okay, so this is we won't get this inverse, so this is completely like bad result. Okay, so always check the condition before getting the inverse of any matrix. Okay, so let me check the inverse of B. Okay, so inverse of B. Okay, so we are getting inverse of B, we are getting some matrix of some good data. Okay, so let me check whether we are getting whether this answer or this command is working correctly or not. So we have that if we multiply B with B inverse, so what it should give? It should give us some, like, it should give us identity matrix. Okay, so matrix A or some matrix A into inverse of that matrix should give you identity matrix. So we are getting calculation was correct. Okay, so this is all in this tutorial. So in next tutorial we'll learn about eigenvalues, eigenvector, and if time permits then integral and differential calculus. Thank you for watching.